All right, get ready, everyone, because today we're diving deep into Android development.
With Jetpack Compose 1.5, no less.
We'll be pulling out all the good stuff from Jetpack Compose 1.5 Essentials.
Written by Neil Smith.
You can grab a copy yourself if you want to follow along. The ISBN 13 is 978-1951-442-835.
It's interesting, this deep dive, it's not just for, the coders out there.
Right.
Even if you've never touched code, we're going to be looking at how those apps you use every single day, how they actually work.
Yeah, it's all about the design, the logic, the magic behind the scenes.
The stuff that makes those user experiences so seamless.
It really is amazing when you think about it. We're going to go through setting up the whole Android development environment.
From scratch.
We're going to learn the basics of Kotlin, even look at things like databases and Google Maps.
All that stuff that powers so much of our digital lives.
Yeah, absolutely. So before we get into the nitty-gritty of coding, maybe let's talk about what we need to get started.
Like gathering your tools before you start a project?
Right. What kind of computer setup will make sure everything runs smoothly?
Yeah, what do we need?
I'm always curious about those system requirements. Is my computer even good enough?
Well, good news is Android development, it's pretty flexible. Windows, Mac OS, Linux, even Chrome OS. You're good to go.
Right?
The key is making sure you have enough memory and storage space, to handle everything.
Makes sense.
We're talking a minimum of 8 gigabytes of RAM and at least 8 gigabytes of free disk space.
Okay, so that'll give the computer some breathing room.
Yeah, just like you need space to spread out your tools and materials for a physical project.
Exactly, yeah. Okay, so let's say we have that perfect computer setup. What's the next step?
Well, the heart of it all is Android Studio. That's the official IDE, or Integrated Development Environment,
Okay.
for building those Android apps. It's our command center, it's our toolbox, it's our everything for making these amazing apps.
Sounds good. I'm ready to download and install. Already feeling that creative energy flowing.
All right, so now that we've got Android Studio up and running, now it's time to, equip that toolbox.
Right.
We need to install the necessary Android SDK packages. SDK stands for Software Development Kit.
Okay.
And these packages, they provide the tools and libraries that we need to build, test, and debug our apps.
So they're the essential tools of the trade. But looking at this list, there are a lot of them. Why so many different packages?
Well, think of each one as a specialized tool for a specific task.
Right.
So we need build tools to compile our code. We need an emulator to test our app on a virtual device.
Yeah.
Platform tools for debugging. It's like having a whole workshop at our fingertips.
Oh, okay.
And of course, we'll grab the Google Play Services package. That opens up a world of possibilities for integration.
So it's not just downloading a hammer, we're getting the whole toolbox.
Exactly. And speaking of essential tools, there's one I want to highlight, the Intel x86 Emulator Accelerator,
Okay.
also known as HAXM. This one is a game changer for making sure that our emulator runs smoothly.
I hear that. No one wants to wait forever for their app to load.
Exactly, especially during testing. So HAXM helps us achieve that during development. Unless you're on an Apple Silicon Mac, those already have fantastic emulators.
No, okay, got it. Speedy emulators for the win. Anything else we need to know about, managing this whole development environment?
Well, there are a couple things that can make your life easier as a developer. First, remember that you can adjust how much of your computer's memory Android Studio uses,
Okay.
especially if you're working on an older machine. Kind of like making sure your workspace is organized so you can move around freely.
Right, right. Keeping things running smoothly behind the scenes.
Exactly. And one more thing. Just like you update your apps regularly, it's important to keep Android Studio and your SDK packages updated as well.
Okay.
Those updates often come with, performance boosts, bug fixes, sometimes even new features.
So regular updates are like giving our tools a tune-up, keeping everything running at its best.
Got it. Okay, I think we've covered that setup process pretty thoroughly. We've got our computer, we've installed Android Studio, we've got our SDK packages. Can we finally dive into the coding part?
Almost. But before we start building, we need to, choose our building materials.
Okay.
And in the world of Android development, that means picking the right programming language. And for this deep dive, our language of choice is Kotlin.
Okay, Kotlin.
It's a modern, powerful language designed with clarity and efficiency in mind.
Sounds good. So why is Kotlin particularly well suited for building these Android apps with Jetpack Compose?
Well, for one, it's incredibly concise.
Okay.
Often, you can achieve the same tasks with fewer lines of code compared to, say, Java.
Ah, I see. So less code, less complexity.
Exactly. Makes it easier to read, to write, to understand, and it benefits users, too.
Oh, how so?
Kotlin has a strong emphasis on safety, which helps prevent those annoying app crashes. When an app suddenly freezes or shuts down unexpectedly. Oh, yeah, yeah. We've all been there.
Kotlin helps us catch and handle those potential errors before they become crashes. So smoother, more reliable experience for everyone.
That makes a lot of sense. So Kotlin helps write cleaner code, less prone to errors, and that leads to better apps. So why Kotlin specifically for Jetpack Compose? Is there something that makes them a particularly good pair?
One of Kotlin's superpowers is its interoperability with Java.
Okay.
That means we can tap into this huge world of existing Java libraries and frameworks. Think of it like having access to a massive library of pre-built components.
Oh, okay.
And that's super valuable on Android. There's a ton of Java-based tools and resources.
So it's the best of both worlds. We've got that elegance and safety of a modern language, plus we can still use all that existing stuff.
Precisely.
Before we get too deep into the technical stuff, is there a way to just play around with Kotlin, get a feel for it before building a whole app?
Absolutely. If you like to learn by doing, there's an amazing online Kotlin playground. It's at play.kotlinlang.org. It's like a sandbox where you can experiment with code snippets,
Oh, wow.
test out different features, get comfortable with the syntax and all the concepts.
That's fantastic. It's like having a virtual coding lab.
Hmm.
All right, I'm feeling ready to start putting these Kotlin skills to use. What's the first step in actually building our app UI with Jetpack Compose?
Imagine you're building a house.
Okay.
You wouldn't just start throwing bricks together, right?
No, you'd need a blueprint.
Exactly. You need a plan. Well, in Jetpack Compose, we use composable functions to define the structure and appearance of our user interface.
So composable functions are the blueprints of our app. Tell me more. How do they work?
Think of a composable function as a self-contained unit that describes a specific part of your interface.
Okay.
It could be a simple text label, a button, or a more complex layout.
Okay.
Now, these functions, they're marked with the @composable annotation that tells Compose, hey, this function, it's meant to emit UI elements.
So it's like saying, hey, compose, this is a special function.
Exactly. And instead of, returning values like traditional functions, composable functions emit those UI elements,
Oh, okay.
which are then rendered on the screen. So those UI elements, they could be anything, text, images, buttons, input fields, you name it.
So they're like little factories churning out UI components.
Yeah, that's a good way to put it.
But how do we combine all these components to actually make a complete user interface? Do we just list them one after another?
Well, that's where the idea of nesting comes in. Just like Lego bricks, you can combine them to make complex structures.
Right.
You can nest composable functions to create these hierarchical layouts.
So it's like building a house where each room is a composable function,
Exactly.
and those rooms are nested within the larger structure of the house.
You got it.
Okay, this is making more sense. But here's a question. How do those UI elements actually react to user actions? Like, if I tap a button, what happens?
That's where the magic of state and recomposition comes in. State and compose refers to any data that can change during your app's execution.
Okay.
Could be the text entered into a field, the position of a slider, items selected in a list, anything.
So it's like the dynamic part of the UI constantly changing?
Exactly, as users interact with it. Now, recomposition, that's the process of updating the UI to reflect changes in that state.
Okay.
What's amazing about Compose is that it's smart. It only redraws the parts of the UI that are actually affected by the change.
Oh, wow. So it's not rebuilding the whole interface from scratch every time something changes?
Well, it's like a targeted refresh.
That keeps things nice and efficient.
Exactly.
All right, let's talk about designing these UIs. We've got our elements, our composable functions, but how do we actually arrange them on the screen to make sure they look good on different screen sizes and orientations?
Well, that's a big question. These days, our apps need to run on phones, tablets, foldables, even desktops.
Right.
So to tackle that, we have Constraint Layout.
Constraint light.
It's a powerful tool. It was introduced way back with Android 7,
Okay.
but it's become even more important with Jetpack Compose.
So constraint layout helps make sure our layouts look great and adapt to different screens.
It does. With Constraint Layout, we can define constraints or rules that control how our elements are positioned and aligned.
It's like giving them guidelines to follow.
Exactly. Make sure everything plays nicely together.
I like that. Let's shift gears a bit. We've been talking about building individual screens, but what about navigating between them? That's a pretty important part of any app, right?
Absolutely. For that, we use the navigation architecture component. It helps us manage transitions between different screens and keeps a coherent backstack.
So it's like a roadmap that guides users through the app.
Precisely.
Okay, so how does this roadmap actually work? What are the key parts?
At the heart of it is the nav host. It's a special composable function.
Okay.
It acts as a container for all our different screen destinations.
Like the main stage where our app screens are performed.
Exactly. Now, to control those transitions between screens, we use the nav host controller.
Okay, so that's like the director of our play.
Precisely. It provides a set of functions that allow us to navigate to specific destinations within our nav host.
Okay. But how do we actually define those destinations, those different screens that our users can go to?
We do that by defining routes.
Okay.
Think of them as unique identifiers, like the address for each screen. And then within our nav host, we use the composable function to connect those routes to their corresponding composable functions, which define the actual content of each screen.
So composable is like the signpost saying, hey, the screen for that route is over here.
You got it. And when we want to move between screens, we use the navigate function,
Okay.
provided by our nav host controller. It's like telling the director, cue the next scene.
This is all starting to come together. So we've got navhost as the container, navhost controller as the director. Routes are our addresses. But any good app needs to handle data, right? That's what powers all the functionality.
Absolutely. Data is essential. It could be user profiles, shopping carts, high scores, anything.
Yeah.
We need to store that information.
Right.
Even when the app closes and reopens. And for that, we have Skidlight.
Squalite. Okay. What is that?
It's a lightweight database engine built directly into Android.
Oh, okay.
It's like having a tiny database right inside our app.
We did a little personal filing cabinet.
Exactly. Ready to store and retrieve our data. Now, to interact with Squidlight, we use a language called SQL.
Squalwell.
It stands for Structured Query Language. Good news is, it's pretty intuitive, easy to learn.
Okay, that's good to know. But is there a way to make those interactions with Squalite a bit smoother?
There is. That's where the Room Persistence library comes in. It's a layer built on top of Squidlight that simplifies things.
Room persistence library. Sounds cozy.
It really does. Room makes those database interactions more intuitive and efficient.
Okay. So how does it do that?
Well, one of the key concepts in Room is entities.
Okay.
Those are data classes that represent our database tables.
So they define what our data looks like.
Exactly. Then we have DAOs, or data access objects.
Mm-hmm.
Those are like interfaces. They define the actions we want to perform on our data.
Like inserting new data, updating, deleting, that sort of thing.
You got it. And finally, we have the Room database class.
All right.
That ties everything together.
Okay.
It's the bridge between our code and the actual Squelette database.
So entities define our data structure. DAOs are the actions. Room database connects everything.
Precisely.
Before we wrap up this part of our deep dive, there's one thing I'm really excited to learn about. Google Maps. How do we get those incredible maps into our Android apps?
Google Maps. To do that, we tap into the Google Maps SDK for Android.
Okay.
It's a powerful set of tools and APIs that gives us everything we need. Displaying maps, customizing them, interacting with them.
Sounds great, but how do we get this SDK? Is it just a download?
It's a bit more involved. To use the Google Maps SDK, we need to get a Google Maps API key.
API key.
It's like our credentials for accessing the service.
Okay, how do we get one of those?
We need to go to the Google Cloud Platform console. That's where we manage all sorts of Google Cloud services, including Maps.
So that's our mission control.
Exactly. We'll create a new project, enable the Google Maps API, and then generate our API key for Android.
Okay, create a project, enable the API, get the key. Got it. But before we get too deep into the technical details of Google Maps, let's pause here for now. We're back and ready to continue our deep dive into the world of Android development with Jetpack Compose 1.5. Last time, we were talking about integrating Google Maps.
Right, getting those maps into our app.
Super exciting stuff. But maybe we should step back for a second.
Okay.
Talk about some more fundamental building blocks.
Like what?
The data types.
Yes. Those are important. It's like learning the alphabet before you start writing. Data types are fundamental in any programming language,
Right.
including Kotlin. They define what kind of information our app can handle.
So like categories for the information.
Exactly. Numbers, text, true or false values, all sorts of things.
Okay, so why are there different types? Why not treat everything just as data?
Well, imagine you're organizing a toolbox. You wouldn't just throw all the tools in a pile, right?
No, of course not.
You separate your hammers from your screwdrivers, your wrenches.
Right. Everything has its place.
Exactly. Each tool has a specific purpose. Yeah. And organizing them makes them easier to find and use.
Makes sense.
Data types are similar. They tell the computer how to handle different kinds of information.
So it's all about making our code more efficient, more reliable.
Precisely.
Okay, can you give me some examples of the types we'll encounter in Kotlin?
Sure. We have numbers, for example. That includes whole numbers, like integers, and numbers with decimal points, floats and doubles.
Okay,
We use those for things like counting items, storing prices, or representing coordinates on a map.
makes sense. What else?
We also have text, which in Kotlin we use the string data type.
Okay,
That can be anything from a single character to a whole paragraph. Think usernames, descriptions, the content of a tweet, you name it.
right, right. So numbers, text, what else?
Booleans.
Booleans.
Yep. They represent truth values,
Mm-hmm.
either true or false,
Okay.
like a checkbox, on or off.
Okay, I see. So it's like the basic ingredients for building the app's logic and functionality.
That's a good way to put it.
But once we have these data types, how do we actually store specific pieces of information?
That's where variables come in. They're like containers for our data.
Uh,
We give each variable a name and assign it a value of a specific data type.
so it's like labeling those boxes in your storage room.
Exactly. You might have a box labeled photos, one for tools, and so on.
Keeps everything nice and organized.
Precisely.
So how do we create these variables in Kotlin?
In Kotlin, we use the val or var keywords to declare a variable.
Okay.
Val creates an immutable variable.
Immutable,
It means its value can't be changed after it's been set, like writing on a stone tablet.
set in stone, got it.
Var, on the other hand, creates a mutable variable.
So changeable.
Exactly. We can change its value later on.
Okay, so val for fixed values, var for things that might change. What if a variable doesn't have a value yet? Like waiting for a user to enter something.
That brings us to nullability. In Kotlin, we can say whether a variable is allowed to be null,
No.
which basically means no value.
Okay.
Helps prevent those nasty null pointer exceptions
Null pointer exceptions, those sound bad.
that can crash your app. But by using the question mark, when we declare a variable, we're saying, hey, this might be empty.
Okay.
And the compiler helps us handle those situations safely.
So it's like a safety net.
Exactly.
Makes sense. Okay, let's talk about controlling the flow of our app's logic. How do we make decisions in our code, execute different blocks of code based on certain conditions?
For that, we use conditional statements. They're the decision-making points in our code.
Conditional statements, all right. Can you give me some examples?
Sure. One of the most common is the if statement.
Okay.
It lets us check a condition and run a block of code only if that condition is true.
So if this is true, then do this.
Exactly. We also have the else statement, often used with if.
Okay.
Defines what to do if the if condition is false.
So if this is true, do this, otherwise do that.
Exactly. And we can chain these together to make more complex logic.
Okay.
And for situations where we have lots of possibilities, we use the when statement.
So that's for more complex decision making.
It is.
Got it. But what about when we need to repeat a certain action multiple times? Seems inefficient to write the same code over and over again.
That's where loops come in. They let us repeat a block of code either a specific number of times or until a condition is met.
Loops, okay.
Two of the most common are for loops and while loops.
Okay.
A for loop goes through a range of values, like a list of numbers,
Okay.
and runs the code once for each value.
So for every item in this list, do this.
Exactly.
Oh,
While loops, they keep running as long as a certain condition is true.
so they keep going until something changes.
Precise.
This is starting to click now.
It's all about building those logical steps. And you'll find these conditional statements and loops, they're super powerful.
I can imagine. There's one more concept I'd love to get a grasp on. Object-oriented programming. I hear it all the time, but I'm not really sure what it means.
Object-oriented programming, or OOP, it's a way of thinking about our code.
Okay.
We organize it in a way that reflects the real world.
Okay.
We think in terms of objects.
Objects like physical things.
Yeah. Think about a car. It has characteristics.
Like its make and model.
Right, its color, engine size, that's data associated with the car.
Okay.
But a car also has behaviors, things it can do.
Like driving, braking, honking.
Exactly, those are the actions.
So data is the car's attributes, and behavior is what it can do.
You got it. Now, in code, we represent those objects with classes.
Okay, so a class is like a blueprint for creating these objects.
Exactly. It defines what data and behavior an object of that class will have. So a car class would outline everything a car object needs.
Makes sense. What about inheritance? I hear that a lot too.
Inheritance is all about creating new classes based on existing ones. It's about reusability and extending what we already have.
Reusability, that's always good.
Less code, more efficiency. Think about our car example. What if we want a class for electric cars?
Okay.
Instead of starting from scratch, we can create an electric car class that inherits everything from the regular car class,
Oh, I see.
but then adds the specific stuff for electric cars,
Hmm.
like battery capacity.
So it's like taking that car blueprint and adding some extra features.
Precisely.
Okay, let's get back to the visuals, the UI. We talked about composable functions. Can we customize how they look and behave?
We can. That's where modifiers come in.
Modifiers.
Think of them as layers of customization that we can apply to those composable functions.
Okay.
We can change padding, alignment, background color, font styles, tons of stuff.
So it's like accessorizing our UI elements.
Exactly. And the best part, we can chain these modifiers together.
Oh, wow. So build up a sequence of transformations. I like it. But how do we actually arrange all these elements on the screen? Control the layout?
That's where layout composables come into play.
Layout composables.
Yeah, they act as containers for our UI elements, defining how they're arranged.
Okay.
Some common ones are row, column, and box.
Okay, so layouts are like the organizers for our UI.
Exactly. A row arranges its children horizontally.
Okay.
Column arranges them vertically.
Yeah.
And box, it lets us stack elements on top of each other.
So row for horizontal, column for vertical, box for layering.
You got it?
What about when we want things to flow more dynamically, adjust to different screen sizes or content?
For that, we have the flow layout composable.
Flow.
It's perfect for letting elements wrap and adjust based on the available space.
So it goes with the flow. Okay. What about lists?
Lists.
Yeah, like for displaying lots of items, contacts, products, posts, that kind of thing.
Yes. Compose handles lists really well using lazy column and lazy row. It refers to how they render those list items.
Okay.
They only render what's currently visible on the screen.
Oh, wow, that's smart.
Saves a lot of processing power, especially for long lists.
Definitely. Even with those lazy lists, sometimes we might want to add headers to help users navigate or group items.
Absolutely. Headers, especially sticky headers, are really helpful.
Sticky headers, those are great. Okay, what about those cool swiping effects?
Like swiping between images or dismissing items.
Yeah, exactly. How do we do that in Compose?
We use pagers. Compose has horizontal pager and vertical pager.
So horizontal for swiping sideways, vertical for up and down.
Precisely.
Okay, those open up a lot of possibilities. But let's talk about bringing some life to our UIs. Animation.
Animations. They really enhance the user experience.
They do make things feel so much more polished. How do we handle them in Compose?
Compose makes it surprisingly easy.
Okay, good.
We have a couple of tools. State-based animations, those are driven by changes in our UI's state. Yeah. And traditional animations, they're triggered by events or run continuously.
So state-based for smooth transitions and traditional for more event-driven stuff.
You got it.
All right, I'm already thinking of all the possibilities. But before we get lost in animation land, let's talk about something important. State management.
Yes. Keeping track of all that data and making sure the UI stays in sync.
Right. That seems like it could get tricky as our app grows.
It can. Thankfully, we have ViewModel to help us.
ViewModel. Can you remind me how those work? Why are they good for state management?
Think of a ViewModel as a dedicated component.
Yeah.
It holds and manages the state for a specific part of our app,
Okay.
like a screen or a feature.
Right.
It sits between our UI and the data layer.
So it's like the middleman.
In a way, yes. It keeps those two parts separate.
Okay, but how does that separation work?
Well, our UI observes the state that the ViewModel exposes.
Okay.
Any changes to that state automatically trigger an update in the UI.
So it keeps everything in sync. View models are our data organizers. I like that. Okay, let's dig a little deeper into databases.
Databases, all right.
We talked about Squally and the Room Persistence Library, but I'd love to understand how they work together.
Sure. Room really simplifies our database interactions. One key idea is the repository.
Repository, what's that?
Imagine it as a central hub for accessing data.
Okay.
It sits between our UI, our view models, and all our data sources.
So it fetches and delivers the data to the rest of our app.
Exactly. It makes things much cleaner and more organized.
I can see that. How do we actually interact with a Room database?
Well, first, we define our entities.
Right, those are like the blueprints for our database tables.
Exactly. Then we create DAOs, those interfaces that define the actions we can perform.
Insert, update, delete, query, all that.
Yep. And then we implement the Room database class, which connects everything to the Squally database.
So entities are our data structure, DAOs are the actions, room database is the connection. Got it. What about relationships between tables? How do we handle those with room?
Room lets us define those relationships using the add foreign key annotation.
Okay.
For example, if you have a customer table and an order table,
Right.
we can link each order to its customer, keep the data consistent.
Makes sense. All right, let's move on to something a bit more advanced. Coroutines. I've heard about them, but I'm not quite sure what they are.
Coroutines are a really cool feature in Kotlin.
Okay.
They let us write asynchronous code in a much cleaner way.
Asynchronous code.
It means code that doesn't run line by line.
Okay.
Some operations can happen in the background while the main part of the app stays responsive.
Oh, I see. So it's like multitasking.
Exactly. Without coroutines, if you did a long task on the main thread, your app would freeze.
Oh, right. That makes sense.
Coroutines let us offload those tasks to separate threads.
Keep things running smoothly. What about concurrency? How does that relate to coroutines?
Concurrency means dealing with multiple tasks happening at the same time.
Right, which sounds complicated.
It can be. Coroutines provide a structured way to handle that, without the mess of traditional multi-threading.
Okay, so they simplify things.
They do. One of the best parts is, with coroutines, asynchronous code looks like regular synchronous code.
Oh, so it's easier to read and write.
Much easier.
Yeah.
No more messy callbacks or threads.
That's a relief. But how do we actually use coroutines with our Jetpack Compose UI?
Compose has a special function called launched effect.
Okay.
It lets us start coroutines within our UI code.
So we can run those background tasks without blocking the UI?
Exactly.
All right, let's talk about those smooth transitions between screens. How do we create those nice animations when navigating?
Compose gives us several tools for that. We have the animated visibility composable, for example.
Okay.
It lets us animate how UI elements appear and disappear.
So like fading in and out.
Exactly. We also have animation specs like tween and spring.
Okay.
They define the timing and easing of our animations.
So we can fine-tune how those transitions feel.
Exactly. And then modifiers like animate, enter, exit make adding animations super easy.
So screens can slide in, fade out, all sorts of cool stuff. Okay, let's not forget about material design.
Ah, yes.
Yeah.
Google's design language.
It's a set of guidelines for creating beautiful and user-friendly apps, right?
It is. And Compose is designed to work seamlessly with it.
Okay.
Many of the standard components in Compose, like buttons and text fields, are inspired by material design.
So it creates a consistent look and feel across Android apps.
Exactly.
But what if we want to add our own style, our brand identity? Can we customize things beyond the standard components?
Absolutely. Compose makes it easy to create custom themes, your own color palettes, font styles, component shapes, you name it.
So we can give our app its own unique personality.
Precisely.
Okay, we can't forget about testing. That's crucial for making sure our app is stable and works as expected.
Absolutely. And Compose provides a great testing framework. We can write unit tests for our composable functions, simulate user interactions, and check if the UI updates correctly.
So we can test both the individual parts and the whole app.
We can. And we can also use the Android emulator or physical devices to run those tests in a real-world environment.
Fantastic. One last thing I want to touch on, permissions. Lots of apps need access to sensitive stuff like the camera or location.
Right, how do we handle that?
Yeah, how do we deal with permissions in our Jetpack Compose apps?
Compose provides ways to integrate those permission requests seamlessly.
Okay, good.
So we can ask the user for permission when we need it, explain why we need it.
Transparency is important.
Very important.
All right, I think we've covered a lot of ground here.
We have, from the basics to some more advanced concepts.
We've covered so much, from setting up our development environment to, those more advanced concepts like coroutines and databases, even touched on Google Maps. It's been quite a journey.
It has.
But I'm curious, how do we actually get our app, this masterpiece we've created, how do we get it out there?
Into the hands of users.
Yeah.
That's the exciting part, sharing it with the world. And for Android, that means the Google Play Store.
Right, the biggest app marketplace for Android.
Millions of potential users.
It's like our app's launch pad.
It is. And to get there, we use the Google Play Console.
Okay, that Play Console.
It's our mission control for managing everything related to our app on the Play Store.
So it guides us through the whole process.
It does,
Yeah.
from getting the app ready to publishing and even tracking how it's doing.
Okay, sounds good. I'm ready to take the controls. What are the things we need to do before we launch?
First, we prepare our app for release. That involves a few steps,
Okay.
like setting the version number.
Right, to keep track of updates.
Exactly. Then we create a release build. That's where we compile our code,
Yeah.
package it all up for distribution.
Okay, so get it ready for the real world.
We also need to sign our app
Sign it.
with a digital certificate. It's like a stamp of authenticity. Verifies who created the app and make sure it hasn't been messed with.
Okay, so versioning, building, signing, those are like our pre-flight checks.
Exactly. Make sure everything's good to go.
Mm.
Next, we create an Android app bundle.
Okay, what's that?
It's a modern way to package our app. It includes everything needed to run on different devices, but it's optimized for size and flexibility.
So it's efficient.
It is. And then we upload that app bundle to the Play console.
Okay, so no need to, like, email it to someone?
Nope, we upload it directly.
Easy enough. So we've prepared our app, created the bundle, uploaded it. Are we ready to hit that publish button?
Almost. There's one crucial step we can't forget.
Which is?
Testing.
Right, of course. Got to make sure everything works perfectly.
The Play console has some great tools for that. We can do internal testing.
Okay.
That lets our team try out the app before anyone else. And we can also set up closed beta testing,
Okay.
where we invite a small group of users to try it and give us feedback.
So we can catch any issues before launch.
Exactly.
All right, but what happens after we do launch? Are we done then?
Not quite. Launching is just the beginning. It's like opening a store. We've built it, stocked the shelves, but now we need to keep things running.
So it's an ongoing process, monitoring the app, making improvements, responding to users.
Exactly.
It's amazing to see how all these pieces fit together. This whole world of Android development with Jetpack Compose, it's really powerful.
It is. And this is just the start of your journey. There's so much more to explore.
Right, it's constantly evolving.
It is.
Well, to all our listeners out there, we encourage you to keep learning, keep experimenting. With Jetpack Compose, you have the tools to create something truly incredible.
And remember, the most important thing is your own curiosity and passion. Keep exploring, keep pushing the boundaries.
That's a great way to put it. We'll be back soon with another deep dive.
Until then, happy coding.
Keep those creative juices flowing.